Okay, so we are now on chapter 9, which is on acid, bases, and salts. No? So basically, we are going to describe, so ano, we are going to describe matter, either kung siya ay acidic or basic, or ano yung behavior niya as a salt, no? After doing the neutralization reaction. Okay, so yun lang yung mga gagawin natin for this session. Okay. So let's differentiate acids and bases. Okay. So yung acids and bases, differentiable yan. No? Kasi na-encounter natin to in everyday life. No? So ito yung mga characteristic ng acid. Ito rin sa base. Okay. O, isa-isahin natin. Acid have a sour taste. Maasim siya. Ibig sabihin, lahat ng maasim na nakakain natin, most likely acid yon. Okay. So for example, suka. Okay. So, yung suka, maasim yun because of acetic acid, yung mga gulay-gulay, mga prutas, no? Example, ano pa ba maasim? Dalandan, no? Mangga, no? So, most likely, maasim sila dahil sa citric acid naman. And then also remember that sa activity series, no? When you react metals with acid, some of them produces hydrogen gas. Okay? Then also sa balancing chemical equation, ginawa natin to last term, no? No. So ayun, alam natin sa balancing equation that acids react with carbonates and bicarbonates to produce carbon dioxide, no? So one example nito is that kapag yung suka ni-react mo sa baking soda, bubula 'yun, 'di ba? Ganon. Bakit 'yun yung ginagamit panlinis ng bara ng CR, no? Kunwari ng kusina, yung baradong sink gagawin mo, lagyan mo ng baking soda, then buhusan mo ng suka. Okay. Kasi yung gas na napoproduce ng reaction, napupush yung dumi. Okay. Napupush yung clog, kaya ayun, yun yung ginagamit panlinis. Okay. Another characteristic naman for the base, sila yung mga mapapait. An example niyan, yung mga gulay na mapapait, no? Example would be yung ampalaya. Okay. So yung ampalaya, medyo weird yung taste niya, 'di ba? Mapakla na medyo lasang bakal. Ayun. Pag natikman niyo yung ganong taste, 'yan, base 'yon. Okay? So one example would be the ampalaya. And yung iba pang gulay na mga mapapakla, may base compounds doon. Ano pa yung mapakla? O, pag naliligo tayo, ano nalalasahan nyo? Minsan yung sabon. Ako kasi medyo ganun minsan eh. Pag naliligo, mamaya tumatalsik yung sabon kung san-san. Ayun, malalasahan mo yung sabon. No? Medyo mapakla siya. Okay? Because ang soap ay gawa sa base. No? So, meron yung sodium hydroxide. Also, ang bases, madulas siya. No? Pag hinawakan mo yan, it feels slimy. Okay? So, yun yung concept ng sabon. No? Yung sabon, when you react that with sodium hydroxide, magiging madulas yun. Okay? So, yan. So, yan yung mga basic characteristic ng acids and bases. Wala naman tayo masyado madadagdag na dyan. Okay? So, basically, we can characterize acids and bases depending on their taste. No? However, in chemicals, no, especially in chemistry, hindi mo pwede lahat tikman. Okay? Hindi pwede tikman yung kung ano-anong chemicals na nasa lab, no? Kasi they are toxic, no? So, ibig sabihin, we should have another way to tell whether a molecule is an acid or a base, no? Okay? Kasi ito yung mga common example lang sa bahay. But what if chemicals yan na ginagamit sa lab, no? Sa laboratory. So, we should find a way to compare, no? Or we should find a way to tell whether a molecule is an acid or base by just looking at the equation and the reaction. Okay? So, yeah. So, bago tayo pumunta sa pag-classify ng acids and bases, no? Let's take note of this na lang. Let's take note of these notes here about the acids and bases. Okay? So, when you say acid, they produce hydronium ion basically, okay? So, sila yung mga atoms na naglalabas ng H+, okay? And yung mga bases, generally sila yung naglalabas ng OH, no? Okay? Okay? So, madidiscuss pa natin tong mga iba dito. Okay? So, ang acid also, it has a pH less than 7. Okay? So, kunwari pH 2, pH 1, yun. Acid yon. For example, our stomach acid is pH 1. Kaya natutunaw lahat ng food sa ating tiyan. Kasi pH 1 yung acid dun eh. No? Yung orange juice, generally, that's pH 4. Kaya maasim-asim yan. No? For example, yung tang orange, di ba? Parang medyo maasim yung lasa niya. Yeah. So, yan. Okay. So, kapag basic naman, ito yung mga pH greater than 7. Okay. So, anyway, madidiscuss pa natin tong mga to later on. Okay. Basta ang alam lang natin is that ang property ng acids and bases ay magkaiba. Okay. So now, punta tayo sa question. Paano mo makaklasify yung acids and bases? Okay? How will you classify them? Okay. One way to classify them is, syempre, hindi pwede tikman yung chemicals sa lab. Ang gagawin mo is just to look at the reaction that happened. Okay? By looking at what happened in the chemical reaction, dun mo pwede masabi kung anong type ng compound yan. Yan ba ay acid or base? Okay? So let's go with some definitions of acids and bases based on some scientists. Okay? Actually, ang daming definition ng acid and bases. No? That's around 10. May mga 10 definition yung acid and bases. But in general chemistry, we only follow 3 basic definitions. Okay? So, ano sabi ni Arrhenius? So, this was the first definition of an acid, no? And the base. Sabi ni Arrhenius way back, I think 17th century yan sinabi. So, sabi ni Arrhenius, yung acid daw, pag nilagay mo sa water, it produces H+. And ang base, it produces OH. Okay? Okay, so ibig sabihin nun, for acids, dapat ang cation niya ay H+, no? Ang cation ay H+. Yun yung positive ion niya. And the anion is OH for the base. Okay? Bigay tayo example ng mga yan. Bigay tayo example. So, one example will be ito. So, we have HCl, for example. Ito. So, yung HCl, pag nilagay mo yun sa tubig, this is muriatic acid. Okay? So, pag nilagay mo yun sa tubig, it dissociates into H plus and Cl minus. Okay? Naghihiwala yung cation and anion. Since ang ating cation ay H plus, ibig sabihin nun, ang HCl ay acid. Okay? So, another way is nitric acid, no? So, yung nitric acid daw, pag nilagay mo sa tubig, it separates, no? It separates as H plus and on nitrate ion. Okay? So, since nag-produce ulit tayo ng H plus, we can say that HNO3, nitric acid, is an acid. Okay? So, ibig sabihin, according to Arrhenius, basta ang iyong molecule naglalabas ng H plus pag nilagay sa tubig, then it is an acid. Okay? So, ganun lang siya kasimple. Okay? Always, ang cation ay H plus kapag Arrhenius acid. Okay? Paano naman daw yung base? So, example ng base nun ay sodium hydroxide, potassium hydroxide, no? So, mangyayari, if you have an Arrhenius base, it dissociates into the cation and your anion, which is hydroxide. Okay? So, kung kanina kapag acid, ang cation ay H+. Dito naman, ang anion ay OH. No? One example will be sodium hydroxide. If you dissociate that, you will produce a sodium cation and OH anion. Okay? Sa pagwalay mo yan, it will produce those ions. Since our anion, okay, so since our anion is OH, ibig sabihin, base yan, Arrhenius base, yung sodium hydroxide. Same thing with potassium hydroxide, no? So if the potassium hydroxide dissociates in water, it produces K plus and OH minus. Since may OH ka mapoproduce, then Arrhenius base iyon. Okay? So yun lang yung definition niya, no? Basic lang. Basta may H plus, acid, basta may OH, base, no? However, Ito, subalit, there are many reactions that cannot be described by Arrhenius. Okay? By Arrhenius definition. Maraming chemical reaction sa paligid natin na hindi nagfo-follow niyan. Okay? Okay. So, kasi ang daming cations other than H plus eh, di ba? Ang daming cations other than H plus. Marami ding anion other than OH. So, ibig sabihin, we should find another way to define acids and bases, no? Kasi hindi lang naman yun yung mga molecules that are acidic and basic in nature. Okay? So, since 17th century pa yung ganap ni Arrhenius na yan, yung mga chemists before, they tried to invent another definition, which led us to the Bronsted-Lowry definition. So si Bronsted and Lowry, dalawang scientists yan. Okay. So according to them, if you have an acid, it should be a proton donor. And ang base, ito yung proton acceptor. Ano ginawa nila? Pag acid, ganun pa rin. Same as Arrhenius. May H plus na binibigay. 'Di ba? Yun yung ginagawa din naman ng Arrhenius acid, 'di ba? So, kinopya lang nila yung idea. So, sabi ni Bronsted-Lowry, kapag acid, yan ay proton donor. Pero, yung pinalitan niya ay yung base. No? Kasi yung mga base natin, hindi lang OH yan. Maraming uri din yan. Okay? So, according to them, instead of the base producing OH, ang ginagawa daw ng base ay siya yung tumatanggap ng proton. Okay? Kumbaga, meron tayong donator, may nagdo-donor, may donor tayo, and meron tayong nag-accept. No? Siya yung mamimigay ng H papunta kay base. Okay? So, yun yun daw yung sabi ni Bronsted-Lowry. So, instead of using H and OH, sabi niya, let's use this na lang. Kung sino yung nagbigay ng H sa yung acid, kung sino tumanggap ng H sa yung base. Okay? And that actually allowed them to describe many chemical reactions. Okay? Yun yung tumulong sa kanila to describe many chemical reactions sa paligid. Okay? So, let's have this example. We have HCl, we have H2O. Okay. So when you combine these two molecules, it produces H3O plus Cl minus. Okay. So now, naka-highlight na kasi. Tatanungin ko sana kayo. Pero nakalagay na yung sagot. Okay. So now, let's explain, no? Bakit kaya sabi dito, acid yung HCl and yung H2O ay base. Okay. Bakit kaya naging ganun yung sabi dyan? Kasi look at the reaction, what happened. Yung HCl mo, pagdating sa product side, nawalan siya ng H. That implies na pinamigay niya yung H. Kanino niya binigay yung H? Kay H2O. Okay? So, binigay niya doon kay H2O yung H. Okay? Ibig sabihin, ito yung donor, ito yung acceptor. Okay? By just looking at the equation, ito H2, naging H3. Ito HCl, ito naging HCl na lang. Okay? So, ganun lang. Just look at the equation and check mo kung sino yung nawala ng H, sino yung nagbigay ng H. Okay? From that, you can tell kung sino yung Bronsted-Lowry acid and the Bronsted-Lowry base. Okay? So, let's have another example. Ito naman. Nakalagay na rin yung answer. So, explain na lang natin bakit naging ganyan yung answer. We have ammonia reacting with hydrochloric acid to produce ammonium ion and chloride ion. Tignan yung reactants products o yung HCl, naging Cl na lang. Okay? Ibig sabihin, nag-donate yan ng H. Kanino niya dinonate yung H? Kay NH3. So, nung binigay niya yung H kay NH3, that made itself an acid and ito ay base. Okay? So, yun yung gusto ni Bronsted-Lowry. Tignan mo lang, sino yung nawalan ng H, sino yung tumanggap ng H, then you can say na ito ay acid, itong reactant na to ay acid, itong reactant na to ay base. Okay? So, very easy lang, no? Itatrack mo lang saan napunta yung H. Okay? So, yan. Di ba yung ating reactant for Bronsted-Lowry definition, may pangalan sila. You have the Bronsted-Lowry acid, you have the Bronsted-Lowry base. dito naman kay Bronze at Lori, yung products, pinangalanan din nila. Okay? So, they tried to name the products as well. Okay? So, hindi lang reactants yung may pangalan. Okay? So, for example, ito, Bronze at Lori acid yan. Ito, Bronze at Lori base. So, hindi lang reactants yung may pangalan. Kundi, meron din tayong pangalan for the products. Ano yung pangalan nila? Ganito. If yung acid nawalan ng H, pagdating sa product side, ang tawag sa kanya ay conjugate base. Okay? Naging baliktad na siya. Okay? So again, ano nangyari? Kapag yung acid mo sa reactant side, nawalan siya ng H pagdating sa product side, ang pangalan ng product ay conjugate base. Okay? So yung acid, pag napunta sa product side, conjugate base. Okay? So similarly, ganun din sa base. Pag siya tumanggap ng H, siya ay magiging conjugate acid. Okay? Now, bakit? Bakit naging baliktad yung pangalan nila? Okay. Kasi, remember, this is reversible reaction. Now, let's explain bakit naging baliktad yung pangalan. If you are going to do the reverse reaction, ibig sabihin yung pabaliktad from products to reactant. So, sino sa dalawa yung magiging acid? Ito. Ito yung magbibigay ng H dito. Parang bumalik tayo dito. Okay? So, ibig sabihin, pag ni-reverse mo yung reaction, ito naman yung magiging acid. Ito naman yung magiging base. No? Okay? So, ito yung reaction na yan. So, ito yung mamibigay ng H dito to produce the reactants. Okay? Ang meaning lang ng conjugate is kabaliktaran. Okay? So, ibig sabihin nun, siya yung kabaliktaran ng base. Conjugate acid. Tapos yung naman, yung acid, ang kabaliktaran niya ay yung conjugate base na. Kasi if you reverse the reaction, magsuswitch yung role nila. Ito yung magiging acid, ito yung mamimigay ng H doon. Para bumalik to. Okay? So yun yung meaning ng conjugate, no? When you reverse the reaction, the roles switches as well. Okay? O yung acid dati, ngayon, base na. O yung base dati, ngayon, acid na. Okay? So yan, take note of that. Okay? So ito, some more examples. We have nitric acid and ammonia. It produces ammonium ion and nitrate ion. So look, sa forward reaction, yung nitric acid, nag-donate yan ng H kay base. No? So ito ay Bronsted-Lowry acid. Ito yung Bronsted-Lowry base kasi yung ammonia yung tumanggap ng hydrogen. Okay? So ibig sabihin, yung nitrate ion, which is a product of this, no, ang tawag sa kanya ay conjugate base. No. Ito naman, yung Bronsted-Lowry base natin, pagdating sa product side, nadagdagan na siya ng H, ang tawag sa kanya ay conjugate acid. Okay? So, magbabaliktad yung pangalan. Okay. So, to help you further with the two, ganito lang. Yung Bronsted-Lowry acid, nababawasan niya ng H pagdating sa product side. No? So, pag nabawasan niya ng H sa product side, conjugate base tawag sa kanya. Pag nadagdagan naman ng H sa product side, conjugate acid tawag doon. Okay? At tignan mo, itong HNO3, nabawasan ng H pagdating sa product. Ibig sabihin, conjugate base yan. Ito naman, nadagdagan siya ng H, ibig sabihin, conjugate acid yan. Okay? Ito, this one naman. May mga sagot na kasi, kaya hindi ako makapag-recitation. Okay. So, how about this one? We have nitric acid and methanol produces methanol cation. Okay. So, yan. So, methanol na may sobrang H and nitrate ion. Okay. So, ano mangyayari dito? Ganito lang. Tignan mo kung nabawasan niya ng H. Ibig sabihin, tawag doon ay conjugate base. Pag yan ay nadagdagan ng H, yan ay conjugate acid. Okay. So, look at this. Ayan. Pagdating sa product side, yun na lang siya. Nabawasan ng H. Ibig sabihin, ang tawag dito ay conjugate base. Ito naman, pagdating sa product side, nadagdagan siya ng H. Tawag doon ay conjugate acid. Okay? So, ganun lang ka-easy, no? Tignan mo lang kung sino yung nadagdagan, sino yung nabawasan ng H, no? By just determining sino yung nadagdagan or nabawasan ng H, you can tell kung sino ang conjugate base, sino yung conjugate acid. Ito. Kunwari, wala kayong nakikitang sagot. Ayan. Let's try to do this, no? Kunwari, tinanong kayo sa quiz, the conjugate base of HSO4 negative. Okay? The conjugate base of bisulfate ion. Ano sabi ko? Kapag conjugate base, babawasan mo ng H. Okay? So, ibig sabihin, ang sagot dapat dyan ay SO4 na lang. Okay? SO4 na lang yan. Kasi nabawasan ng H, di ba? Again, take note. Kapag sinabing conjugate base, babawasan mo ng H yan. Okay? So, yan. Paano yung charge? Okay, paano yung charge? O, negative 1 to. Pag tinanggal mo yung H, mas magiging negative to. Okay? So, mas magiging negative yan by 1. No? So, ibig sabihin, kung negative 1 yan, pag tinanggal mo yung H dyan, magiging negative 2 na siya. Okay? Bakit? Kasi yung H, positive 1 yung charge niyan eh. Okay? So, kung tinanggal mo yung positive 1 na charge dito, ano yung charge talaga nito? Edi negative 2. Kasi pag pinagsama mo yung dalawa, positive 1, negative 2, equal yon sa negative 1. Okay? So, ganun. So, yan. So, again, kapag tinanggalan mo ng H, yung charge, gagawin mong minus 1 pa uli. Okay? So, from negative 1 ngayon, negative 2 na. About letter C, the conjugate base of phosphoric acid, H3PO4. Sabi ko uli, kapag conjugate base, isang H lang tatanggalin mo. Okay? So, it will be H2PO4. And since nagtanggal ka ng isang H na positive, ibig sabihin negative to. Okay? So, yung H kasi positive. So, kung kinuha mo yung positive 1, edi magiging negative na yan. No? Okay. So, ganun lang yung idea dyan. This one naman, the conjugate acid of NO3. So, to know the conjugate acid of NO3, ano sabi ko kapag conjugate acid? You add H. Magdagdag ka lang ng H. Isa lang. Okay? So, isang H lang. And what will happen to the charge? No? Sabi ko nga, yung hydrogen positive yan. So, kung negative 1 to, mag-plus 1 ka, 0. So, kapag 0, wala kang isusulat. No? Ayan yung sagot. Again, always ang hydrogen positive, no? So, kung tinanggal mo yung hydrogen, magiging negative lalo yung molecule. Pero kung nagdagdag ka ng hydrogen, magiging positive yung molecule. Okay. Kung ilan hydrogen dinagdag mo, edi plus 1. Letter D, we have the bioxalate ion, hydrogen oxalate ion. Now, conjugate acid, ibig sabihin, magdadagdag ako ng H. No? So, that will become H2C2O4. How about the charge? So, negative 1 yan. If I add 1 hydrogen, magpa-plus 1 ako sa charge. So, negative 1 plus 1 is 0. So, wala na tong charge. Okay? So, yan yung ating mga sagot. So, ano yung pwedeng takeaways natin dito? Ang unang pwede nating gawing notes na lang siguro is ganito. Kapag conjugate base, magbabawas ka ng hydrogen, then yung charge minus 1. Okay? Magbabawas ka ng isa sa charge pag tinanggal mo yung hydrogen. Yung conjugate acid naman, magdadagdag ka ng hydrogen. Mangyayari sa charge, magpa-plus 1 ka. Okay? Ganun lang ka-easy, 'di ba? So easy lang, no? Parang ang dali, no? Ganun talaga, madali lang kasi. Wag lang mako-confuse, ha? Okay. Ayan, so we're almost done. Malapit na tayo sa kalagitnaan. Hindi, joke lang. Matagal-tagal pa tayo. So ayan, yun yung Bronsted-Lowry definition. How about the Lewis, no? Ito. Ang Lewis naman, this is a modern definition. Okay? So si Lewis, ang ginawa niya is ganito. So instead of defining acids and bases based on the hydrogens, no, and hydroxide. So imbes na yun yung basis nila for acids and bases, si Lewis, ganito yung naisip nila. Ang base, yun yung donor ng electron pair. Ibig sabihin, lone pair. Sila yung namimigay ng lone pair. And yung acid, yun yung tatanggap ng lone pair. Okay? So, yun. Ang base ay lone pair, donor. Ang acid ay lone pair, acceptor. O, nagkabaliktad na yung role nila. Kung dati, yung acid sila yung namimigay parate. Ngayon, sila na yung tumatanggap ng lone pair. Okay? So, bakit kaya kailangan nila, bakit kailangan nila baguhin yung pangalan, definition ulit, no? Kasi there are chemical reactions that, there are chemical reactions that cannot be described by, by Arrhenius and Bronsted-Lowry. Okay? For example, in this reaction, we have the H plus and we have the OH, no? Okay. So we have the H plus, we have the OH. Okay. So obviously, yung H plus acid yon, yung OH ay base yon. Okay. So medyo obvious pa dyan. Pero mamaya hindi na yan obvious. No? So I'll show you later. So what will happen when the base donates a lone pair to the acid? Ano mangyayari kapag dinonate niya yung lone pair sa acid? Ganito. Ilang electrons kailangan para magkaroon ng chemical bonds? 'Di ba dalawa? There should be 2 electrons to create a chemical bond. So mangyayari is that kapag yung Lewis base nag-donate ng electron pair to Lewis acid, magkakaroon sila ng connection. Magdudugtong sila. Ayun. Magkakaroon sila ng bond. Okay. Kasi 2 electrons yung binigay niya. So, ibig sabihin, pwede na sila magsama. Okay. So, another example would be this one. Itong Lewis base natin. Ito. Hindi to hydroxide, pero pangalan nito ay base. Bakit? Bakit naging basic ang ammonia? Kasi, it donates the lone pair to the hydrogen, no, to create a bond. Okay? So, since it donated the lone pair to the hydrogen, base siya. Lewis base siya. Okay? So, ganun. So, yan, as it donates the lone pairs, no? The lone pair to the hydrogen, nagdudugtong sila. Ayun. Ito, this is this is uncommon reaction. No? Wala siyang hydrogens na pinamigay. Ibig sabihin, you cannot use the Arrhenius. You cannot use the Bronsted-Lowry. Okay? Pero this is acid-base reaction according to Lewis. Bakit? Sabi ni Lewis, pag nagbigay ng lone pair, ano yon? Base yon. Kapag tumanggap ng lone pair, acid yon. So, for this example, we have boron trifluoride. Okay, so we have boron trifluoride and ammonia. So, acid-base reaction to. Bakit? No? Kasi, in order to create the product, ammonia donated the 2 electrons kay bromine. And again, pag dinodonate yung dalawang electrons, nagkakaroon ng bond. Nagkakaroon ng chemical bonds parate. Okay? So, yun yung ganap ni Lewis. Okay? So, yun lang. So, those are the 3 definitions of acids and bases na. Okay? So, again, let's recall. Pag Arrhenius acid, H plus donor. Naglalabas siya ng H na cation. Pag base naman, naglalabas siya ng OH anion. Binago yun ni Bronsted-Lowry, no? So, according to Bronsted-Lowry, yung hydrogen yung focus natin. Kapag yan naglabas ng hydrogen, pag naglabas ng hydrogen or proton, yun ay acid. Kapag naman siya yung tumanggap ng hydrogen, siya yung base, okay? So, binago nila. So, instead of using OH as the basis for the base, sabi niya, yung proton acceptor, yun yung base. Ano yung addition sa atin dito? Yung acid, pag naglabas yan ng H, magiging conjugate base yan. And yung base, kapag yan ay tumanggap ng H, siya ay magiging conjugate acid. Ano uli meaning ng conjugate? When you say conjugate, kabaliktaran. Okay? So, naging kabaliktaran siya. Because if you reverse the reaction, the role will be opposite then. Yung acid dati, siya na yung base, no? Yung base dati, siya na yung magiging acid. Okay? Take note of that, no? Pag binaliktad mo yung chemical reactions, magpapalit ng role. Kunwari, from this, pabalik doon. Okay? From this, pabalik doon. So, ito yung magbibigay ng H doon para mabuo to. Okay? So, nagkabaliktad ng role. Kaya nga, conjugate. Ibig sabihin, kabaliktaran. Okay? So, yun lang. And then lastly, the Lewis acid definition, Lewis acid-base definition. So, basically, sabi ni Lewis, pag yung lone pair denonate, yun ay base. Pag ang lone pair ay tinanggap, yun yung acid. And then yung significance nito. We can now describe reactions without hydrogens transferred, no? So, pwede ka na mag-describe ng reaction kahit hindi yan, kahit walang hydrogen dyan. Okay? So, ganun. Ayun lang. Okay? So, those are the three definitions of the acids and bases. Ito yung summary. Okay, so yan yung summary. Arrhenius acid produces H+, Arrhenius base, OH-. Pag Bronsted-Lowry, you have the base accepting the acid, yung Habio acid, losing the proton, okay? So yan. Yung acid magiging conjugate base and yung base magiging conjugate acid, no? Kapag Lewis definition naman, ano lang ganap na ito? So, pag Lewis definition, basically, yung magdodonate ng lone pair, yun yung base. Yung tatanggap ng lone pair, yun yung acid, no? Okay. So, ganun. And this is actually helpful sa organic chemistry. Okay. So, in organic chemistry, usually, wala kami masyadong hydrogens doon. Pero the reaction are occurring. Okay. So, to explain those reaction from happening, ano yun? Lewis definition gamit namin doon. Okay? So, ayun lang. Okay? So ito, isang application to ng mga acids and bases in our body. Okay? So, in our body, we have stomach acid, which is basically hydrochloric acid, no? So, maasim yan. Kaya nga, di ba kapag nasuka tayo, let's say, kunwari, galing sa inuman or masama pakiramdam, di ba pag sumuka ka, sobrang asim. Kasi, yung sikmura mo, punong-puno ng, HCl, muriatic acid yung nandyan sa tiyan mo. To be honest, mas matapang pa nga daw yung acid sa sikmura natin kaysa sa muriatic acid na nabibili sa palengke. Okay, or sa grocery. Ay sabihin, ganun talaga, no? Ganun katindi yung pantunaw ng tiyan natin. Kaya, yung pagkain natin, tunaw agad, no? Maya-maya na lang. Mamaya, mafe-feel mo, ay, kailangan ko na mag-CR, diba? Lalo na pag busog na busog. Okay. Ganun katindi yung ating stomach. Okay. Ngayon may ask, no? Ba't kaya hindi nabubutas sikmura natin? Ang tapang-tapang pala ng acid sa sikmura. Okay. Kung nakakita na kayo ng itsura ng stomach ng manok. Okay. Kunwari, bumili kayo ng whole chicken. Okay? Yung patay na, no? Nakakaawa kaya pumatay ng manok. So, kunwari, bumili ka whole chicken. Pag binuksan mo yung guts nun, yung stomach, hiwain mo yon. Pag binuklat mo yon, ang kapal ng stomach. As in, super thick. Ganun din sa tao, makapal yung stomach. Okay? So, the stomach is a very well-defined structure, very well-defined organ sa body na makapal siya so that kapag natunaw yun ng acid, mag-shed off lang siya. Okay? Ibig sabihin yung acid, tinutunaw niya yung loob ng stomach mismo. But, ganito, yung molecules, I mean yung mga cells sa stomach, mabilis mag-replace. Okay? Para makapal pa rin siya, hindi siya numipis, no? Okay. Ang tanong, kailan magiging manipis yung ating layer, no, ng stomach? Kapag ikaw may mga chronic diseases, no. For example, you have the GERD, no, the gastroesophageal reflux disease, no, the GERD, o kaya you have and nagpapalipas ka ng gutom, ayan, pwede mabutas yung sikmura mo. Literal na mabubutas, okay? So, kunwari, ikaw, nagpapagutom ka, papalipas ka ng gutom, hindi ka kumakain, no? Kasi ayaw mo kumain. Di ba, ma-feel yun, sakit-sakit ng sikmura nyo. Kasi, that's one way of our body telling na kumain ka na, or else bubutasin ko sikmura mo. Parang ganun yung ganap ng stomach natin, no? So, sabi niya, pag sumasakit na yan, kumain ka na. Okay? Kasi baka mabutas yung stomach. So, literal na butas yan, no? So, ganun. Another way to resolve that, for example, you have the GERD or the hyperacidity. Pwede tayo uminom ng Kremil S o kaya Gaviscon, 'di ba? So, ano meron dun sa mga Kremil S, Gaviscon? Mga bases. Kasi we know that the acid reacts with the base, no? Okay. So, pag nag-react yung dalawang yon, magiging babalik sa normal yung pH natin. Okay? So, ibig sabihin, when our bases react with the acid, tataas yung pH, no? So, ano yung resulta nun? Hindi nasasakit yung sikmura mo. Kung kayo nagki-Kremil S, ako kasi madalas ako mag-Kremil S, no? Kaya ito, share ko na. Sana hindi kayo kumakain kasi ganito yung share kong kwento. Pag ako, nag-hyperacidity, inom ako Kremil S, mamaya-maya lang, mafe-feel mo ang gassy ng sikmura mo. Tapos magfa-fart ka. Okay. Bakit, no? Kasi, yung ating Kremil S, other than the hydroxide, it also contains bicarbonates, no? Nakalagay doon, magnesium hydroxide, magnesium bicarbonate. Okay, when bicarbonate reacts with acid, nagpo-produce yun ng CO2. Kaya after mo uminom yan, either dumighay ka or umutot ka. Okay, so ganun yung mangyayari, no, kapag uminom ka ng antacids. Yan, because of the presence of bicarbonates and the bases, no? Okay. So yan, sana aware kayo, no? Para kunwari sumakit sikmura nyo, feel nyo nangangasim kayo, alam nyo na gagawin nyo. You buy Kremil S. 5 piso lang yan. Okay? So wag nyo tiisin yung sakit ng sikmura, ha? Okay, so ganun lang. Ako usually kasi, nung college ako, nasisikmura ako pag umaga. Kasi umagang-umaga, nasanay ako na hindi ako kumakain nun, no? Kasi face-to-face pa yun eh. So, kailangan mo talaga pumasok eh. Diba? Alam nyo naman yun, diba? Pag late ka, lahat na. Parang galit ka na sa lahat, diba? Pag late ka na. So, yung kailangan maaga ka talaga gumising. So, hindi na ako kumakain nun. Tapos, ang nangyayari, na-hyperacidity ako nun minsan. So, kaya may Kremil-less ako parati sa bag na. Yun. Pero, ayun nga. So, tinigil ko rin yung practice na ganun. Okay, so, kumakain na ako everyday. Pagdating ng school, PUP pa ako nun eh. Doon ako nag-undergrad. Pagdating PUP, bili agad ng food, no? Kain habang nagkaklase. Okay lang naman sa prof eh. So, ganun. Then, sa work from home, wala, hindi ako nagbe-breakfast. Nasanay ako sa brunch. Okay. Kaya minsan nafe-feel ko yung sikmura ko nangangasim. Ayun. Iinom ako ng Kremil S ulit. Okay? Pero again, huwag nyo hayaan mangyari yun, ha? Dahil delikado din. Ako kasi alam ko kung ano gagawin ko kasi alam ko yung chemistry behind that. So, okay lang sa akin. Pero kayo, be mindful of your health na lang. Okay? So, yan. Let's proceed. Let's talk about amphiprotic substances. When we say amphiprotic substances, these are substances that can either be an acid or a base. No? So, it could be an acid or a base. Amphiprotic. Okay, so ibig sabihin, dalawa yung roles niya. Pwede siyang acid minsan, pwedeng base yan minsan. And the common amphiprotic molecule is water. Okay, bakit? Let's look at the two reactions below. So looking at this first reaction, ano nangyari? The nitric acid donated the proton to the water. So ibig sabihin, ito yung acid, ito yung base, no? But on the other reaction, what happened is that the water donated the hydrogen to ammonia, so making it an acid, no? So ibig sabihin, yung role ng water ay dala-dalawa. Pwede siyang acid, pwede siyang base. Okay? And if you have a molecule which acts as an acid and base, ang pH nun most likely ay 7. Okay? So yun, kaya yung water, pH 7 yan at neutral, no? Kasi amphiprotic siya. Both acid and base siya at the same time. Okay? And so yun yung idea. Okay? So pag tinanong kayo, which is the common amphiprotic acid, ang sagot natin ay water. No? So minsan acid siya, minsan base siya. Another explanation dito is syempre, saan ba gawa yung water? H plus and OH. You have the acid and the base property in one molecule. Okay? Kaya ganun. Ang water ay ang amphiprotic, common amphiprotic substance. Okay? So, ganun. Baka kasi isipin nyo, sabi dito, base yung water, ibig sabihin base yan all throughout. No. That depends on the reaction. So, minsan base siya, minsan acid siya. Okay? Tawag doon ay amphiprotics. And now, let's proceed. Tinitignan ko kung ano tayo. Yung concept lang tayo masyado ngayon, ha? Okay. Sige. Ibig sabihin, medyo malapit na matapos tong session natin. Okay. So, concepts lang, then onting calculation ngayon. Okay? So, next one. Yung acids natin, it could be monoprotic or polyprotic, no? Okay. So, ano meaning ng polyprotic, no? Pag sinabing monoprotic muna, mono, ibig sabihin, ano ibig sabihin ng mono? Isa. Ang protic meaning nun, hydrogen. Ibig sabihin nun, kapag if you have monoprotic acid, isang hydrogen lang ang kaya niya ibigay. Okay? So, an example nun na ito, nitric acid, isang H lang kaya niya ibigay doon. HCl, isang H lang kaya niya ibigay doon. So, they are monoprotic. O yung suka, ganun din. Suka, CH3, COOH. Okay. So, may ganito yan. Yung suka, ito, acetic acid, it donates one hydrogen to this. So, tapos yung reaction. Monoprotic yon pag ganun. If your acid can only produce one hydrogen. Paano mo malalaman? Just look at the equation. And look at the subscript of acidic hydrogen. Okay? So, yan. Ito yung acidic hydrogen. Now, let me highlight. Ayan. 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 Ayun. Ngayon, ano naman yung polyprotic? From the word poly, ibig sabihin, marami. Protic meaning hydrogen. So, more than one hydrogens ang kaya niya i-donate. No? So, the common example of the polyprotic acid ay carbonic acid, phosphoric acid, sulfuric acid. So, yun yung mga common example. And ano nangyayari kapag meron kang polyprotic acids? Okay. Kasi siguro isipin nyo, di ba? Kapag polyprotic acid, sir, ganito. Dinodonate niya agad yung dalawang hydrogen. Okay? It seems logical, yes, no? Kasi dalawa yung protons na pwede niya i-donate. Ibig sabihin, dalawa na i-donate niya agad-agad. But in reality, that's not true. When your polyprotic acid donates the hydrogen, isa-isa yon, okay? Stepwise siya. Okay, so ibig sabihin, isa muna, then yung susunod na acid, yun yung susunod. Okay? So stepwise yung process. No? It is actually stepwise. Okay? So ibig sabihin, punta muna tayo dito sa aking example na sulfuric acid. Oopsie. If you have sulfuric acid, H2SO4, isa-isa yung pagtanggal ng H. Okay? So isa muna. So you have H plus and HSO4. Ngayon, wala ka ng H2SO4, lahat sila naging ganito na. Okay. So, ito naman yung maglalabas ng isa pang H. H plus and SO4 negative 2. Okay. So, stepwise yan. Okay. So, isa-isa lang. This is the first ionization. This is the second ionization. Okay. The first ionization, isa lang yung H na matatanggal. Then, yung matitira na conjugate base, pwede mo pakunan ng hydrogen yan for the second ionization. If you get the overall reaction, ano yung overall reaction yan? Ganito pa rin. Okay, so ganyan pa rin yung overall reaction kasi magka-cancel out ito eh. Ayan. So magka-cancel out yan. Pero, again, mas maganda na aware tayo na hindi nangyayari to agad, no? Hindi siya isang bagsakan na magbibigay siya ng dalawang hydrogen, no? Hindi isang bagsakan yung pagbigay niya ng hydrogen. Parang stipend yan sa scholarship. Hindi naman isang bagsakan yan, di ba? Monthly yan, di ba? May DOSC scholar sa inyo, 7K ngayong buwan, o next month, 7K uli. Ganon din dito. Sa polyprotic acid, isa-isa lang. Okay? Kasi kapag binigay mo agad yung dalawa, ang yaman mo nun. Okay? So, ang yaman agad. No? Milyonaryo ka na. No? Ganon pag scholar ka. Naalala ko tuloy yung first stipend ko sa DOST. Delayed kasi kami nun. Ibig sabihin, ang tagal namin hindi nagkaroon ng stipend, wala kaming pera. Then, yan, isang bagsakan, ang laki ng pera. Ang kulang na lang ipaypay mo sa sobrang kapal ng pera. Ayan, so I think pwede kayo mag-apply ng DOST din. Okay, share ko lang. So, yan, ganun yung kapag polyprotic acid, no? Hindi isang bagsakan yung pagbigay ng hydrogens. Stepwise, no? One by one lang. So, ganun din for carbonic acid, H2CO3. So, yung isang H muna babaklasin mo. Okay? And then you will be left with the conjugate base. And ngayon, yung conjugate base naman, ito naman yung magtatanggal ng isa pang H. No? Okay? If you get the overall reaction, ang overall reaction yan ay ganito. Okay? Plus 2H2O. 2H3O plus CO3. So, yun. Mawawala yung conjugate base na bicarbonate. Pero again, stepwise yung process. Hindi yan isang bagsakan na dalawa agad yung ilalabas niya. No? One by one. Same thing with polyprotic acid. For example, phosphoric acid. Okay. So, for phosphoric acid, so H3PO4, isa munang hydrogen. Ayun. So, after nyan, isa pang hydrogen babaklasin niya. Then, lastly, last hydrogen. Okay. So, 3 steps. Depending on the number of H, ganun karami yung steps sa pagbaklas ng hydrogen. Okay. And as you can see, polyprotic acids are described by equilibrium system. May equilibrium arrow tayo, no? So, ibig sabihin, this process is reversible. Ayan. So for every step, there is a corresponding dissociation constant. Okay, there is a corresponding acid dissociation constant. Okay, so yun lang. Ano naman sabi dito sa slide na to? Number of hydrogen cannot always be used to classify. Anyway, so yan. So let's proceed na. Okay, so let's proceed. Acid-base property of water. Let's go back to water. Because we know that water is amphiprotic, no? Amphiprotic siya. So it serves as an acid and a base at the same time, no? So ibig sabihin, in our water system, kunwari, kuha ka ng tubig ngayon sa ref, yung water doon sa baso mo, acid and base yon at the same time, okay? So yung water natin, it reacts with water to produce hydronium ion and hydroxide ion. Okay? So ganun nangyayari. If you have two water molecules in your substance, pwedeng ito, kunin niya yung hydrogen nun. Okay? So ibig sabihin, ito ay Lewis base, ito ay acid. Yan. So ganun. Ibig sabihin, yung water natin, sila yung nagkukuhaan ng hydrogen. Okay, to produce H plus and OH. No? Okay? So, ano yun? We can quantify that. No? Remember that if you have an equilibrium system, you can write KW. Okay? You can write a K expression. Di ba, ito yung lesson natin last time. Pag may nakita ka nito, you can write K. No? K is the equilibrium constant. Okay? So, since ito ay water, ang K natin ay tatawagin nating KW. Ibig sabihin yan, the equilibrium constant of water. Other than equilibrium constant, product. No? So, yan po yung isang term. Equilibrium constant of water, ion product of water. Okay, so let's do that. Now, how to write the K? Okay, so suppose ito yung ating reaction. You have water, auto-ionizing is into H plus and OH. You write as H plus and OH, no, divided by water. And since sabi ko nga sa inyo, yung water, hindi isusulat yung water, di ba? So you can remove that, no. So you can write KW equals to this. Bakit yung water di isusulat? Kasi nga, liquid yon. Okay. Constant yon. And sinabi din dyan, constant, di ba? So yung water, di mo yan isusulat talaga. So you can just simply remove it, no. And your K can be written as H plus times the OH, di ba? Yung products, minumultiply sa numerator. That KW is called the ion constant, ion product of water. Okay. And that is equal to 1 times 10 raised to negative 14. Okay. Yung KW, that's equal to 1 times 10 raised to negative 14. If equal yung concentration ng H and OH, so if equal ito, pati ito, ibig sabihin you have a neutral solution. Okay. So, ano yung neutral solution? Ang concentrations nila ay 1 times 10 raised to negative 7. So, kapag equal yung concentration ng H sa OH, neutral yan. But, if mas maraming acid, no, kaysa sa base, acidic yung solution mo. And kapag mas maraming OH, naka-screen share ako. Di ba nakikita sa'yo? Siguro I can reshare na lang the screen. Okay. Baka humina yung internet dyan. Lumaki na yung mukha ko ulit. Ayan. Makita na. Kita na dyan, Bianca. Naka-share na ko ulit. Ayan, okay. Minsan kasi ganun, no? Pag bumabagal internet. Nangyayari yun sa amin sa Zoom, pag nagkaklase ako. Ayan. Anyway, so yan. Yan. Saan ako nawala? Balik ulit tayo dito sa taas. Okay. So yun, sabi ko nga, if you have an equilibrium system, you can write the K expression. K expression is product over reactant. Okay, so ito yung product over reactant. And yung reactant, H2O, since liquid yan, hindi yan nasusulat. You can just simply erase that and you will get KW. Okay. KW is the ion product constant of water or the equilibrium constant for water. And at 25 degrees Celsius, KW is 1 times 10 raised to negative 14. Okay? So sabi din dito, if ang ating H and OH equal sila, then you have a neutral species. You have a neutral solution rather. If mas maraming H, malamang acidic yan. Kapag mas maraming OH, malamang basic yan. Ano implication nito? Ano implication nito? Ano naalala nyo about pH scale? 'Di ba up to 14 yan? Up to 14 yan. Saan galing yung 14? Hulaan nyo. Galing yon dito. Ayan o. Andyan yung 14 o. Okay? So, ibig sabihin yung pH scale natin ay based dito sa concept na to. Okay? 'Di ba from 0 to 14 yon? Ayan. Dito yon galing. Okay? So, later on, papakita ko sa inyo yung pH scale. Okay? Pero at least, dapat ngayon pa lang nakikita natin, ay, dito pala yung galing. Okay? So, bakit hanggang 14 lang siya? Ito yung dahilan nun. Yung KW. Okay? Yung kasi yung product niya at 25 degrees Celsius. Okay? Before tayo mag-proceed sa pH scale, let's try to solve for this one. Ito, madali lang naman. Okay? Kaya nilagay na yung solution. What is the concentration of OH in HCl solution whose hydrogen ion concentration is 1.3 molar? Okay. Ganito, pag hinahanap sa inyo yung concentration ng OH given yung concentration ng H, you use this, no? Bakit? Bakit ito yung equation na gagamitin ko? Kasi kung ito yung hinahanap given to, pwede mo i-solve to. Okay. You just do simple algebra. Okay? Ano hinahanap? Yung OH. So, ibig sabihin, I have to divide both sides by H+. Okay? So, magka-cancel yung H. So, ang magiging equation ko will be KW over H+. Okay? So, yan. Ka-cancel ko lang yung H+ na to. Divide both sides by that. I will get this equation. OH equals KW over H+. Now, what is KW? KW is always 1 times 10 raised to negative 14 at 25 degrees Celsius. Okay, so ganun siya at 25 degrees Celsius. So basically, ipa-plug in mo lang yun sa KW. What's the concentration of H+? Ito. Ano yung concentration ng H+? HCl binigay sa atin, sir. Ganito. Ano alam natin? Yung HCl ay 1.3 molar. If this dissociates into ions, we will have H+ and Cl-. Yung concentration nila ay same lang din with the previous one. Okay? So 1.3 molar din yung mga yan. Okay? So ganon. Again, take note of that, ha? Okay, kapag yung HCl natin, it dissociates into ions, kung ano concentration na to, yun din yung concentration ng ions niya. Okay? The same lang din. What if may coefficient yan? You may ask, kunwari, what if, sir, may coefficient yan? Kunwari, we have barium hydroxide. What if may coefficient yan? Barium hydroxide, pag nilagay sa tubig, magiging ganito yan. Isang barium ion, dalawang hydroxide ion, di ba? Okay. So, ito, 1.3 molar yan. Ano yung concentration ng products? Yung barium, 1.3 pa rin yan. Pero yung OH, magiging 2.6 yan. Okay? Bakit na? Ganito kasi, kapag may coefficient ka doon, ibig sabihin, ito times mo yon sa kanyang molarity. Twice yung dami niya eh. Yun yung meaning ng coefficient, diba? So, twice ng OH yung mapoproduce mo. Ibig sabihin, ito times 2 mo to. Kaya magiging 2.6 yan. Okay? Share ko lang, no? I don't know kung lalabas yan sa quiz, no? Sila na kasi yung gumagawa ng quiz. Eh. Pero yun yung idea, ha? Pag may coefficient, i-multiply mo yon sa concentration. Pag 1 lang naman yung coefficient nila, edi same lang. Okay? Take note of that. Now, so according sa ginawa natin kanina, HCl is 1.3 molar. So basically, plug in mo yung Kw, H+. Pag dinivide mo yan, you will get this number. 7.7 times 10 raised to negative 15. Okay. Question, is this solution acidic or basic? The solution is acidic. Bakit siya acidic? No? The solution is acidic. Bakit? Yung concentration ng H+, which is 1.3, compare mo yan sa OH. 7.7 times 10 raised to negative 15. Sino mas malaki? 1.3 o yung times 10 raised to negative 15? Ang mas malaki ay yung H+. Sabi natin earlier, pag malaki yung H+ kaysa sa OH, acidic yung solution. Okay? So take note of that, ha? Pag mas marami yung H+ kaysa sa OH, acidic ang solution. So you're just going to compare the two. Kung sino mas marami. Obviously, yung 1.3. Kasi ito decimal to eh. Okay? Ang ganun lang. Let's have some example pa. Some example. Dito na lang ako sa small space dito. Suppose that barium hydroxide, this is 0.05 molar. Find the concentration of H+. Identify if acidic, basic, or neutral. Suppose we have 0.05 molar barium hydroxide. I want you to look for the concentration of H+. And you have to identify whether that's acidic, basic, or neutral. Okay? So, I'll give you few minutes, no? Siguro mga 3 minutes lang. Mabilis lang naman to sagutan. And let me zoom out para alam niyo yung solution na susundan niyo. But take note may mga coefficient to. May mga coefficient akong nilagay doon. So, the concentration of OH must be correct. Okay, so I'll give you 3 minutes to try to answer this. Then I will show the solution. Zoom in nyo na lang yung screen kapag hindi makita masyado. Okay, so let's solve, no? Sagutan natin to. So, ano gagawin natin is that we should know first the concentration of the hydroxide, no? Okay. Sinabi ko na naman that if you have a coefficient, you multiply its concentration. Okay? So, ito, still 0.05 molar yan. But, yung OH, ito ay magiging 0.1 na. Bakit? Kasi times 2 yun, no? Twice yung dami nito kaysa dito. Okay? So, ito times 2 mo yung concentration. Okay? So, now I know my concentration of OH. Then, to solve for, H+, I have to use KW. KW equals H plus OH minus. I am looking for H plus, so I can write the equation as H plus equals KW over OH. Okay. Now, what's KW? KW is 1 times 10 raised to negative 14. OH is 0.1. Divide natin. So, H plus is 1 times 10 raised to negative 13. Yun yung sagot. And the question is this acidic, basic, or neutral solution? Your answer should be basic. Why? Bakit siya basic? Kasi, yung concentration ng H plus mo is less than the concentration of your OH. No? So, the concentration of H plus is less than the OH. Ibig sabihin, this is basic solution. Okay? Nakuha nyo naman ba? Nakuha nyo naman yung sagot. 1 times 10 raised to negative 13, then basic dapat. Sana nakuha kasi marami pang mangyayari sa calculation dito. Ayan, good. Marami pang calculation na pwede mangyari. Okay? Kaya sana makukuha yung basic problems pala. Okay? So, ganun lang ka-easy. Dali na. Okay. And now, let's talk about pH. pH is the negative log of H+. What is log? Ito ay function. And this is logarithmic function. Okay. So, log is a logarithmic function. Okay. So now, based on the idea of the concentration of OH, in acid, neutral, or basic solution, we can determine anong pH siya, acidic or basic. Okay, ganito. Sabi natin, when we have a neutral solution, H plus is equal to OH. And that means 1 times 10 raised to negative 7 yung H plus. Siguro nagtataka kayo, no? Saan galing to? Saan galing to? Okay. Dito yung galing sa KW. Okay? So, let me derive this muna. Diba remember, KW, H plus yan, times OH minus. If etong dalawa ay equal, we can let them as X, diba? X yan, tas ito, X din. So, that's KW equals X squared. So, if I want to solve for X, that's the square root of KW. Ang square root ng 1 times 10 raised to negative 14 ay 1 times 10 raised to negative 7. And this is equal to H plus and OH minus. Doon galing yung 1 times 10 raised to negative 7. Hindi siya gawa-gawa lang ng Illuminati. May derivation yan. Okay? So, yan. So, ibig sabihin, if you have a neutral solution, the H concentration is exactly 1 times 10 raised to negative 7 molar. Okay? But, if you have acidic solution, this concentration will be higher. Mas mataas yun than this. the H plus concentration will be greater than this. If you have a basic solution naman, that means the H concentration is lower than 1 times 10 raised to negative 7. In terms of pH, ano mangyayari? Ganito. In terms of pH, let's plug in the concentration sa pH. So pH is negative log 1 times 10 raised to 14. Now basically, times 10 raised to negative 14 lang. Lagay ko. Okay, ayan. pH is negative log 10 raised to 14 or 1 times 10 raised to negative 14. Ano ba nangyayari dito? No? I mean, 7 pala to, sorry. Ano ba nangyayari dito talaga? Bakit siya naging pH equal to 7? Ganito po. Kasi sa math, no? Pag meron tayong logarithmic function at may exponent doon, yung exponent lumalabas, no? Okay. So pH is equals to negative of negative 7 log 10. Yun yung sabi sa math, okay? O, hindi yan gawa-gawa lang, no? Sa math talaga yan galing. So yung exponent na negative 7, if you have a log function, lalabas yan sa harap. Ito negative 7, mapupunta doon. What is log of 10? Pag pinindot nyo sa calc yung log of 10, ang sagot ay 1. Okay? So this is 1. So basically, pH is negative 7. Negative 7 times another negative 7 yan. So for neutral solution, the pH is equal to 7. Okay? So the pH is equal to 7. Ngayon naman, if you have an acidic solution, the concentration of H is greater than this, no? 1 times 10 raised to negative 7. And yung pH, lower than 7. Bakit naging opposite yung trend, no? Bakit kaya baliktad, no? Kasi kung mas marami dapat to, ba't hindi tumataas? May kinalaman yung negative sign doon. So remember, yung negative sign, it means baliktad. No? Baliktad yung relationship. Kaya kapag tumataas yung H concentration, bumababa yung pH. Kasi nga, because of the negative sign. Kung tumataas to, bababa to because of the negative sign. Ayun. So that's why if we have pH less than 7, we can say that that solution is acidic. And if we have H concentration less than this, then kung mababa to, mataas to. So pH is greater than 7 kapag basic yung solution. Okay? So again, don't confuse yourselves. Pag lower than 7, acidic. Pag higher than 7, basic. Pag equal to 7, yan ay neutral. Take note that the relationships are inverse. Bakit sila naging inverse? Just because of the negative sign. Okay? So, yan lang. Other important relationships. Ito naman. So, yung pH is for H+. Ibig sabihin, meron ding OH. POH yun. Okay? So, POH tawag doon. Kapag in terms of OH naman yung concentration. And saan lumalabas yung pH scale na equal to 14? Di ba? Kwento ko yon dahil dito sa KW. Let's derive paano lumabas yan. Okay? Paano naging pH scale is up to 14? De-derive ko na lang para mas ma-appreciate natin. We know KW is H plus OH minus. What's KW? That's 1 times 10 raised to negative 14. Okay? Ngayon, mag-algebra ako. So, I will take the negative log of both sides of the equation. Ano mangyayari? So, this will become negative log 1 times 10 raised to negative 14 equals negative log H and OH. Applying the properties of logarithm, pag may multiplication ka sa loob ng logarithm, pwede mo sila paghiwalayan. Okay? So that will become negative log 1 times 10 raised to negative 14, negative log H, negative log OH. Pwede mo yung paghiwalayan pag may multiplication sa loob ng logarithm. Yun yung sabi ng algebra. Now, what's negative log of 1 times 10 raised to negative 14? This is 14. Pag pinindot nyo yan sa calcu, 14 sagot dyan. What's negative log of H? That's pH. What's negative log of OH? Adi, POH. Ayun, dun lumabas yung pH scale natin. The sum of pH and OH is 14. Kaya ang pH scale natin ay up to 14. Okay? So, ibig sabihin, hindi lang siya gawa-gawa, no? Meron talaga siyang derivation. Okay? So, hopefully, naka-clarify yung questions natin before nung high school. Kasi ako nung high school, tinatanong ko to sa teacher ko eh. Sabi ko, bakit po 14? Ay, ito pala yung sagot. College ko na nalaman na yan yung sagot. Wala naman kasi kami senior high nun eh. Ako yung second batch before before K-12. Okay. So 2014 ako nun. 'Di ba nagkaroon ng K-12 2016. Ayun. So second batch before K-12 ako. Kaya diretso college ako. Kaya maaga ako nakagraduate. Ayun. So, since wala kaming senior high nun, hindi na nabalikan yung chemistry. No? Kasi sa senior high ngayon, nababalikan yung chemistry, di ba? Physical science, o kaya kung STEM kayo, edi Gen Chem. Ayun, tinuturo ko yan sa mga students ko. Ayan. So, yun lang yung reason bakit ang pH scale ay up to 14. Ito naman, ito some basic calculations to. Nawala. Ayan. So, these are some basic calculations. Ayan. Paano to sinagutan? Describe natin. Describe natin to. Paano siya nasagutan? The pH of rainwater collected in a certain region of northeastern United States on a particular day was 4.82. What is H? Okay? So, ang binigay ay pH. Ang hinahanap ay yung concentration. Is it possible? Yes. Let me show the derivation. Paano nakuha yan? Okay? Gagamit ulit tayo ng properties of logarithm. Dito tayo. Ang logarithm, yung h plus, nasa loob siya ng logarithm, di ba? Pag yun yung sinusolve mo, yung h plus, kailangan ilabas mo siya sa logarithm. Yun yung gagawin natin. Okay. So, ayaw natin yung sinusolve natin nasa loob ng logarithm. Okay? Kasi, kailangan ilabas mo siya doon, di ba? Ganun, di ba, pag nagsosolve sa algebra, kailangan tanggalin mo yung sinusolve mo sa loob ng function. Okay. So, yun yung gagawin natin. Okay, so I want that h plus to be outside the logarithm. Paano? Multiply ko muna both sides by negative. So, magiging ganito yan. Ngayon, ano yung pangontra sa logarithm? Ano yung pangtanggal ng log? Sabi sa algebra, ang pantanggal sa logarithm ay gawin mo yung exponent ng 10. Okay? So basically, itong equation ko na to, i-erase ko to, ay gagawin ko siyang exponents ng 10. Okay. So this will be 10 raised to negative pH, and this one will be 10 raised to log h. So sabi ni algebra, if you have 10 raised to log, magka-cancel out yung dalawang yan. Magka-cancel out sila. Dun lalabas yung h plus. So H plus is 10 raised to negative pH. Pakisave na yung equation. Okay? So again, paano natin nakuha to? This process is called the anti-logarithm. Logarithm. Okay. So we just did the anti-logarithm, no? Meaning ng anti, tinanggal natin yung log. So according to algebra, para matanggal yung log, gawin mo siyang exponent ng 10. Ginawa natin yan sa both sides ng equation. Ito, ginawa natin exponent ng 10. Ito din, ginawa exponent ng 10. Yung log and 10, simply mawawala sila. You will get the H. And on the right side, you have this expression. So what's left for you to do is to plug in the pH. No? Lalagay mo na lang ang pH. No? Ayun yun. H equals 10 raised to negative pH. 10 raised to negative 4.82. Type mo na lang sa calcu yan. You will get this answer. Okay? So pakisave yung... Ay, nabura ko. Anyway, na-delete ko. Okay. So ito yung equation to determine the concentration of H plus from the pH. Ano naman kapag concentration ng OH? Di 10 raised to negative POH. So, pakisave tong additional equations natin. Okay, pakisave ha. Ayan. Next one. The OH concentration of a blood sample is 2.5 times 10 raised to negative 7. What is the pH of the blood? Okay. So, dalawa yung pwedeng gawing way mo dito. You can have two processes here. Okay. So, pwedeng unang process. Okay. Saan ko kaya pwede? Dito na lang. Sige. Solution 1. Ganito yung una mong pwede gawin. Concentration ng OH, convert mo to POH. Then yung POH, i-convert mo to pH. Yan, tapos ka na. You will get the pH of the solution. Another solution will be this one. You have the concentration of OH. Gawin mo yung concentration ng H. Then, saka mo kunin yung pH. It should give you the same answer. Okay? So, gagawin ko, I will do both of them. Para makita nyo na same yung lalabas na answer. So, yan, same lang. Pag ni-round off. No? Again, pag ni-round off. Kasi mamaya magra-round off ako eh. So, let me show you that. No? So, dito tayo. Saan kaya? Dito na lang. 2.5. Okay. Sabi natin, solution 1. Solution 1. So, gagawin ko yung OH, gagawin ko ang POH. Ito na pala yun. Ito na yung nakasulat dito. Ayan. Ito yung solution 1. Itong nandito nakasulat. So, yung concentration ng OH, ginawang POH. So, yan, negative log OH. Gawin mong POH. Ito yan, 6.6. Then, from this, you know that pH equals, you know that 14 equals pH plus POH. So, since hinahanap mo yung pH, lipat mo yun sa kabila. 14 minus POH equals pH. That's why you have this equation. Transpose lang sa other side. So 14 minus POH, so that's 14 minus 6.6 equals 740. Okay, so ganun lang ha. Lipat-lipat lang. Now, I will do the second approach. Itong pangalawa. Concentration ng OH, gagawin kong H, then saka ko kukunin yung pH. And I should arrive with the similar answer. Kailangan nyo makuha kong answer ay malapit. Kasi mamaya magra-round off ako. Solution 2. Pinapakita ko yung ways to solve, no? Para hindi kayo limited sa isa lang. Mas maganda kasi na nakikita nyo na ang daming ways to solve for the problem. Okay? So, ayoko mas stuck kayo sa isang, isang process. No? So, ayan. So, from OH concentration, gagawin kong H plus concentration. Ano gagamitin kong equation dyan? KW. Pag-usapang concentration, KW. Ayan. Hinahanap ko yung H plus, no? So, H plus KW over OH. KW is 1 times 10 raised to negative 14. OH is, ano sabi sa problem? 2.5 times 10 raised to negative 7. Divide lang natin. 1 times 10 negative 14 divided by so that's 4.8. 4 times 10 raised to negative 8. Burahin ko lang, nagkamali ng sulat. Ayan. Zoom in ulit, zoom in. 4 times 10 raised to negative 8. And then now, pH is negative log of this. 4 times 10 is to negative 8. pH is negative log of that, which is 7.397. So, 7.40 naman din yan. Okay. So, consider many steps. No? There are many ways to solve for the problem. As long as you know the equations to be used, no, you can use the KW equals H plus OH. You can use the pH equals, pH plus POH equals 14. Okay. So, interchangeable yung mga equations na yan. Okay. So, yan. Pinapakita ko lang sa inyo that, yung ating equation can be used, no, sa maraming equation na pwede tayo gamitin sa isang problem. Okay. So, huwag kayong maging stuck sa isang equation lang. Okay? Ayan. Let me open the lights kasi ang sakit na sa mata. Ayan. Para maliwanag yan. Okay. Dali lang ng calculation ngayon, no? Sa ngayon, madali lang. Pero later on, hihirap na yan. Okay? Next meeting na natin pag-usapan yung mahirap na calculation. Okay. So for the last part of our session today, let's talk about the strengths of acids and bases. Okay. So generally, we have two types of acids and bases. No? Dalawa yung uri nila. Meron tayong tinatawag na strong acid, meron tayong tinatawag na weak acid. Meron tayong tinatawag na strong base, meron tayong tinatawag na weak base. Ano yung problema? Ano yung difference? Ganito lang. Pag sinabi natin strong acid and bases, these are molecules which are completely in ionic form. Ibig sabihin, yung dissociation dito is complete. No? So for strong acids, this dissociation is complete. Ibig sabihin nun, lahat ng atoms maghihiwalay. Magiging ions sila. Pag sinabi nating weak naman, pag sinabing weak acids and weak bases, incomplete dissociation yan. Incomplete dissociation. Okay? So, yun yung difference lang. Pag sinabing strong acid, the dissociation is complete, 100%. Pag sinabing weak acid, yun na ay mga incomplete dissociation. Now, how will you tell if a molecule is a strong acid or a weak acid? Strong base or weak base? Paano? Okay, so you can use this diagram. Okay, so you can use this diagram kasi nakalista na dito yung mga chemicals that are strong and weak. Okay. So generally, you will have a strong acid if eto. So you will have a strong acid if that is hydrohalide acid, no? HCl, HBr, HI, with exception to HF. Later, kwento ko bakit exception si HF, no? Kasi kabilang siya dito eh, fluorine, hydrogen, fluorine, chlorine, bromine, iodine. Pero bakit siya nandun sa weak? Kwento ko yon later. So ito yung mga strong acid if you have hydrogen bonded with halide except fluorine. Okay. Oxo acid, meaning that is an acid with oxygens. Okay. So for example, nitric acid, sulfuric acid, ano ba yung chlorate, may chloric acid. Ayan. Napaisip tuloy ako sa pangalan. Yung 8 gagawing ik plus the word acid. So this is chloric acid and perchloric acid. Ayun. Ayan yung mga strong acid natin. Ayan. So yan yung mga strong acid. And then we have the weak acids. We have the acetic acid, hydrofluoric acid, hydrocyanic acid, carbonic acid, boric acid, and phosphoric acid. Okay. So let me explain itong HF. Ang HF ay considered as weak acid because it forms hydrogen bonds. Okay. So it forms hydrogen bonds eh. Ibig sabihin makapit siya sa hydrogen. Ayaw niya humiwalay. Clingy. Masyado siyang clingy. Kaya naging weak acid siya. Parang sabi niya, uy, maghiwalay na tayo. Sabi niya, ayaw ko. O yun. Weak acid siya. Okay. So ganun lang. Yun lang. Because of hydrogen bonds. For strong bases naman, these are molecules that contains hydroxide and oxide ions. For example, lithium hydroxide, sodium hydroxide, calcium oxide, potassium oxide, calcium hydroxide, and barium hydroxide. Pag weak bases naman, these are generally molecules which has nitrogen. Okay? So instead of having oxygen, nitrogen naman sila. And so we have ammonia, what's that? Ethylamine, dimethylamine, okay? And then we have, ano kaya to? I'm not really sure kung ano itsura ng molecule na yan. Kasi may mga isomers sa orgchem. Anyway, so hindi ko napapangalanan yan. Kasi I don't know if what isomer is this pertaining to. But those are the weak bases. No? So kapag strong bases, generally sila may mga oxygen. Weak bases sila may mga nitrogen generally. Okay? So going back, sabi natin, if we have a strong acid, the dissociation is 100%. No? So if you have, for example, sodium chloride, okay, so ito, hindi to acid, no? Sodium chloride, pag ito nag-dissociate, 100% yan. Magiging sodium yan and chloride ions, no? Kaya kapag yung asin nilagay mo sa tubig, completely nawawala siya. But for suka, ano meron sa suka? Hindi siya completely nawawala. Kaya medyo cloudy yan, di ba? Medyo cloudy yung suka. I was showing kasi noon, yung mga particles, hindi siya completely dissociated. Okay, so yan. So acetic acid that is not completely dissociated. And always, kapag hindi complete ang dissociation, they are described by equilibrium arrows. No? Ibig sabihin, basta makakita ka ng equilibrium arrow, automatic weak acid yon. Okay? So basta makikita ka ng equation na may equilibrium arrow, automatic weak acid yon. Yun yung shortcut ko. So di ko naman talaga kabisado lahat yan. Although familiar ako, pero ang first na tinitignan ko talaga is the equilibrium arrow. Pag nakita ko may equilibrium arrow yan, ibig sabihin weak yan. Weak acid yan or weak base yan. Okay? So ganun lang. So, yan na nga, strong acid, 100% dissociation, no? And it produces weak conjugate base, no? Ayan. And these are the strong acids that we encounter. Ayan. Weak acids, ito yung mga onti lang yung nadidissociate because of equilibrium. Okay? So, the equilibrium lies on the left. Ibig sabihin, more reactant than product. So, ibig sabihin, hindi fully converted ito to products. Okay. And this produces a stronger conjugate base. No? So, kapag mahina yung acid, strong ang conjugate niya. So, kung mahina ang base, strong ang conjugate niya rin. Okay. Ito yung mga strong bases which are described earlier. As you can see, kapag hydroxide ang inyong anion, limited ka lang, no? Onti lang options mo because of the solubility rules, no? Yung hydroxide kasi, with some metals, nagpe-precipitate siya. Okay. Kaya, ayan. Ayan lang yung options natin. Onti lang. Okay, take note again, kapag strong acid, full yung dissociation. Pag weak acid, may equilibrium. Strong base, full yung dissociation. Pag weak base, may equilibrium. Okay, so ganun lang. Kwento-kwento na lang. We have the conjugate acid-base pair. Sabi nga natin, in a Bronsted-Lowry definition, yung acid, nagpo-produce yun ng conjugate base. And yung base, nagpo-produce yun ng conjugate acid. Okay? So, ganito. The strength of the acid is inversely related to the strength of the conjugate base. Ibig sabihin, kapag strong yung acid mo, weak yung conjugate base mo. And kapag weak yung acid mo, strong yung conjugate base mo. So, inverse ang relationship nila. Okay? So, parang yung sa H lang din, pati OH. Kapag mataas yung H, mababa yung OH. Pag mataas yung OH, mababa yung H. Ganon din dito. Kapag strong yung acid, mataas yung H. Weak ang conjugate base, mababa ang OH. Okay? So, yun lang yung idea dito. So, the stronger the acid is, the weaker the conjugate base is. Hindi nyo kailangan kabisaduhin yan. Okay? And the weaker the acid is, the stronger the conjugate base becomes. Okay? So the relationships are inverse, no? Because of what we established sa KW. Okay? Pag mataas yung isa, mababa yung other one. Okay? Pag mataas yung concentration ng acid, meaning strong yon, weak yung magiging base natin. So on and so forth. Okay? Again, take note that yung ating acid, it becomes fully dissociated. Ibig sabihin, if we have HCl, pagdating sa product, 100% magkahiwalay sila. But if you have weak acid, hindi yan 100%. Okay? Mostly reactant, then only onting product lang yung ma-form natin. Okay? So, ganun lang. So, let's define this. Last na to for this session today. Kasi alam ko ang dami ng info na pumapasok sa utak niya. Okay. So last for our session today, let's define concentrated and diluted acid. Generally, we say that the acid is concentrated kapag ang kanyang molarity ay 1 and above. Okay. Okay. Kapag naman diluted, yun yung mga decimal yung molarities. Anyway, hindi naman to masyadong important. Ayun. Next meeting, we will discuss this. No? We will discuss the ionization constant for acids and bases. So, please review your equilibrium. Okay? Kasi gagamitin yung natin yung equilibrium. And take note that mag-algebra tayo. Gagamit tayo ng quadratic equation. Okay? So, bibigyan ko kayo ng shortcut dito. Don't worry. Ako bahala sa inyo. Okay, so yan. Puro tayo next time. Puro math. No? Okay, so anyway. So that will be our session for this day. Puro math tayo next meeting. Okay? Ay, scan ko na. Okay. So, yun lang. So, that will be all for our session today. Na? Okay. Reviewin na lang uli yung equilibrium, ha? Okay. So, I'll see you again next meeting. If you want to have a copy of the PowerPoint, andun lang siya sa Canvas. Teka, buksan natin yung Canvas. Ang daming info, no? Kaya ako nililimit ko yung class ko to maximum na yung 2 hours, 30 minutes. No? Kaya yan. Kasi nga, ako nag-aaral din naman ako ngayon. No? Ang classes ko sa masters, umaabot ng lagpas 3 hours. Nakakabangag kaya. Nakatulala na lang ako minsan. Kaya ginagawa ko less than 3 hours ginagawa ko sa inyo. Okay, punta lang kayo dito sa canvas natin, bandang baba, ayan. Ay. Nalipat na naman ito. Akyat ko na lang siya ulit. Wait lang. Akyat natin. Ayan. Okay, so ayan. So, hanapin nyo yung module 8 ng laboratory. Andoon ang PowerPoint. Ito yung PowerPoint. Okay, so yun lang. Yung quiz dito, I think, katulad din yun ng mga previous quizzes, no? Okay, may experiment din. Okay, so anyway, wag kayo magpapatambak ng quizzes ha. Kasi medyo dumadami na yung quizzes niyo, unti pa lang nagpapasa. So, wag niyo hayaan na matambakan kayo, no? Kasi every week may quiz na talaga tayo. Okay. Ang deadline naman yan is sa finals week, no? Pero again, don't submit on the last day ng finals kasi I am planning to encode your grades as early as I am planning to encode your grade as early as May 25, no? Para may grades na kayo. And ayan, mag-i-email din ako ng scores nyo. Okay. So hindi siya required, no? Ibig sabihin yung mga faculty, hindi nila gagawin 'yon. Hindi required kasi yung consultation for the finals. But ako, I will do it, no? Para lang may copy kayo. Pero again, that's not required, no? Baka mag-expect kayo sa other faculty. Pero ayun nga, hindi nila gagawin 'yan for sure. Kasi hindi naman required. Okay? So that will be all, no? So if you have any questions, don't hesitate to ask lang. Okay? I'll see you again next Friday. Okay, so next Friday. So ayan. So I'll see you again and ingat always. Bye-bye. And yung copy ng video will be uploaded on YouTube as well. Ingat parati.